We're going to start by going over our vocabulary so that as we're going through the lesson, when we use these words, we know what we're talking about. So the base is the number that's being multiplied, or it's the, let's say first say it's the big number. And then what that number is that it's a number that gets multiplied. So then the base here would be the 2. The exponent, or the small number, is how many times to multiply. So the exponent here would be 3. So this tells me that I'm going to multiply the base of 2 by itself 3 times. So I'm going to multiply the 2 3 times. So 2 to the third would be 2 times 2 times 2. Or that would be 8. And then the power is not actually a different word for exponent. Power means this whole thing together. So 2 to the third all together is the power. Okay, so we did an activity to review some special rules here, so let's write them off to the side. Exponent of 1, the answer will always be itself. So like 8 to the 1 would equal 8. A to the 1 would equal A. And then exponent of 0 is always 1. So that means that, for example, 7 to the 0 is 1, or x to the 0 is 1. And then the last rule that we learned was the negative exponents. And then if it's a negative exponent, we learned that it is not a negative number. So I want to make a note of that. Not negative number. What it does mean is you need to move or flip, take the reciprocal of any negative exponents, and however you want to word that. So like number 1, for example, it has a negative exponent. So negative exponents, that does not mean my answer is negative. It means I'm going to have a fraction, so I need to flip this upside down. So I like to think of it as a fraction, so I can always make any number a fraction by putting it over 1. And then the 1 is just a placeholder, so we can just ignore the 1. We're going to focus on this part here that has a negative exponent. X to the negative 8. It's in the numerator, so we need to move it down to the denominator. And when I do that, it becomes positive 8. But I can't separate the x and the 8. That is a power, it stays together. Exponent and base always have to stay together for what we're doing right now. And then I can't have nothing on the top of a fraction, so we put a 1 again for a placeholder. So the answer would be 1 over x to the positive 8. Similar in number 2, except so that 1 is just the placeholder there. We have m to the negative 3. There's my negative exponent. It needs to move up because it's on the bottom already, so we can't move it down, so instead we move it up. Now I don't need that 1 in the top anymore. I mean, technically it's there, but if I multiply anything by 1, it's not going to change. And then, so I had this fraction bar, but there's nothing left in the denominator. I could put a 1 there for a placeholder, but then this wouldn't actually be simplified. So typically, when we have nothing left in the denominator, we can just get rid of the denominator, and we can say that's just m to the third. On number 3, any number like this 3 that does not have an exponent technically does. It's a hidden exponent of 1. So that 3 is really 3 to the first power. And because I have a negative exponent, I want to make it a fraction. And the better you get at these, you might not need to always make the fraction like that. Well, Okay, so we said with negative exponents, we're only going to move or flip the negative exponents. So that 3 has a positive exponent. So we're going to leave that 3 in the numerator right where it's at. But that x has a negative exponent, and it's in the numerator, so we need to flip it or bring it down to the denominator. So it's going to become x to the positive 5 in the denominator. Similar in number 4, except that x we have to move is already down, so it's going to move up. But the 7 has a positive exponent, so that 7 is going to stay in the numerator where it's at, but I need to move that negative up, so it becomes x to the positive 2. Now there's nothing left in the denominator. Again, I could put the 1 there, technically, but then it's not simplified. But dividing by 1 doesn't change anything, so that's just going to keep it 7x to the second. So we had to bring these up when we have this 7 and this x next to each other. That actually means they're being multiplied. So anytime we bring something up or down, we're actually just multiplying it by each other when they're next to each other now. Number 5, think of it as a fraction. The 8 has a positive exponent, which means it can stay in the numerator where it's at. But both the x and the y have negative exponents. That means both of those need to move. So these both need to move. They're up right now, so they need to move down. So the x ends up in the denominator to the positive, and the y ends up in the denominator now to the positive 8. Number 6, they both have negative, so they both need to move. So the x needs to go down, but then the y needs to go up. So the y ends up being on the top as a positive to the positive 8, and the x ends up being on the bottom to the positive 4. Because remember, the whole point of moving these or flipping them and taking the reciprocal is because that makes the exponent the opposite. And we never want to have a negative exponent. It's not simplified if we have a negative exponent. Okay, this next part's really similar, but we have actual values that we can simplify further or evaluate. So number 7 is very similar to number 1, except instead of a variable, we have a number. So I'm going to think of it as a fraction. It has a negative exponent, so it needs to move down. So that's going to become 3 to the positive 3. I have nothing on top, so I need a placeholder. Unlike number 1, where I could just stop because I don't know what x is, I know what this variable is, and I know what this value is. 3 to the third is exactly 27. So with values like this, with numbers, if you can evaluate, you need to evaluate. Number 8, similar to number 2, so I'm going to move this up to make it positive. And we can just ignore that 1 because that 1 was kind of there as a placeholder. But once we have this up there, we don't need it. And then if we leave it as a fraction, we would see that there's nothing on the bottom now. Again, technically there's a 1, but I don't need to write the 1. If I'm dividing by 1, it doesn't change anything. I can actually do 2 to the 5th though. Remember, that means 2 multiplied by itself 5 times. And that will give me 32. Number 9. This one's a little trickier. So we've got extra steps involved. The 3 has a positive exponent. It's a hidden 1, so it can stay where it's at. But the 5 needs to move up. So I already have the 3 up here. Now I'm going to move the 5 up here. So like we said over on this one, those are being multiplied. Same thing here. So now that I have both of these in the numerator, they're just being multiplied. So we really have 3 times 5 to the second. And I'm going to add another note off to the side over here. Order of operations. Something that we don't really talk about a lot anymore, but we can't forget. Order of operations says that we need to do exponents before we can do multiplying. So then on number 9, I would have to do that 5 to the second power, or 5 squared first. 5 squared is 25. Now I can multiply. 3 times 25 is 75. I would get a very different number if I had accidentally multiplied the 3 times 5 first and said 15 to the second power. That'd be, I think, 225. Very different answer. So we still got to follow order of operations, always. And then we get to some easier ones. anything to the 0 power is always 1. So let's go ahead and do 13 also. Negative 2 to the 0. Anything to the 0 is always 1. And then while we're on it, let's start looking at number 14 because I see 3 to the 0. So 3 to the 0 has to be 1 because anything to the 0 power is always 1. But I still have 2 to the negative 3. So we'll come back and finish that one in just a second. Let's look at number 11. Anything to the first power is always going to be itself. So 7 to the first is 7. Negative 4 to the first is negative 4. Now let's look back at number 14 and we're going to finish up this problem. It's not simplified because we still have a negative exponent. But we've done a couple problems like this. So this needs to move because it's negative. It's already in the bottom, so we're going to move it up to the top to make it positive. And now because we move that up, there's nothing left in the denominator, so I no longer need a denominator. And I can just finish solving this because 2 to the third means 2 times 2 times 2, and that is exactly 8. So this thing here, all this weirdness, is just a weird way of saying I have 8. So make sure you're practicing those exponent rules because we're going to start seeing these mixed in with other rules in bigger problems.